Okay, so last time we had our client, when our client connected, a decision was being made by our client. In fact, here we can just start our server up, I think. Well, our server's actually still running, but we'll unrun that. So we'll start our server up. Our server's running. We have two separate clients. We're deciding that we have one client who's in charge of getting the ball rolling. So this is our share client. So this guy's going to connect and say, I'm going to share this file. And I think we have that share client doing some initial stuff here. What do you want to do? Share or get? This guy will say share. Which file do you want to share? We're going to say that. So he has said the file. The server then received that this client is going into sharing mode. So it now knows that something's happening. And I don't think we have anything for our get client yet.
You had the server running that whole time, like since last class?
Yeah. You never know if people. Okay, yeah. So we did have something. So now the client connects. This is the get client, the one who wants to get a file, and they connect and they say we're ready to receive. And the server showing us the name of the file and how big the file is. Okay, that's the only file our server knows how to serve at this point. Okay, so our model currently looks like this. So this was our first little get server here, but we could certainly have two other guys connect, and they would all be ready to receive that one file. And each of these guys has this array, this collection. And their goal is to fill up this array with bytes. How many bytes? Well, we know that we need this many bytes. Okay? So every single client that connects is going to get the number of bytes that they need to create to capture bytes coming in. So if we go back to the connected client, let's see, actually this is the client communication protocol, right? So here's our start communication. What do you want to do? Do you want to share or get? Share calls the share stuff, which is this guy up here. So he reads in the file, figures out what file you want, reads it in, then tells the server name of the file and how big the file is. So the server becomes aware of these pieces of information. What does the server do with that? That's the server's response thread. They read it in right here. They get the file name and they get the file size. Then they take this one connected client and initialize the bytes, its byte array, to the size and true. Actually, it's not a byte array, it's a Boolean array, isn't it?
Yes.
That's connected client. This guy has a Boolean array of actual bytes, and this guy's going to, when we initialize it, it's going to hold whatever Boolean value we collect. So this is going to be, in this case, a Boolean array of size 45,626 filled with trues. Okay, because the guy who's sharing, this guy already has all the elements of the file. Make sense? He already has all the elements of the file. Now we have our getting client connect. So he connects, and the server spits out, we're in getting mode now, and we send out the message to the client. Here's the file name we can serve, and here's the size of that file. And then we init the bytes. We init the Boolean array to false. That client currently has no bytes of it. Make sense? All right, so what we're doing here is the server is housekeeping. The server is keeping track of all this data about all of its connected clients. So in our current model here, we have this set up. So let's call this guy, he's client A, he's client B. Okay, so the server knows about the one, well here, yeah, the list of clients and what bytes they have. So right now we have, where can I put this? We'll have to make it look different. Let's do a list. So this is A, and this guy currently has all the bytes. And then we have B, and he has none of the bytes. Okay? All or none. Right? But these are going to turn into numbers. So what is this actually? 45, 45626. So this is 45626, and this is 0. Okay. Now keep in mind these are not actual bytes. This is a Boolean, an array of Booleans that dictate how many bytes each of these guys actually has. These guys each have their own byte array here, which actually holds the bytes. Make sense? All right, so we go back to our client communication protocol. And if we are in sharing mode, what are we doing? When we say that we are locally buffered the file, we have this array called the file bytes that's filled up with ints. That's our byte array because it needs to hold unsigned bytes, so 0 to 255. What we need to do in our client is we need to make this array global. We need to have access to it. Actually, do we need to have it global? Not necessarily. Yeah, it's fine. We can have it local. Doesn't matter. All right, so this guy is going to have fizz bytes available, or fizz available for file bytes. This guy down here, you know what? I lied. He's going to go global. It's just the way it works. Deal. So this is going to be a private int array, but we're not going to give it a value yet. We're just going to define it up there. So every client communication protocol has an array called the file bytes. So then down here, when we are in this guy, we're just giving it a value. We're not redefining it. So if we're sharing, the file bytes is going to be however many bytes are currently available in our local stream. And then we'll go ahead and read that in to our file bytes. This is why this guy has 100% of the bytes. Okay, the server has assumed, since this is the dude sharing the file, that he must have the file. Therefore, he has 100% of the bytes, so we're going to read it in locally. And that's the whole reason why we're only doing this with like a JPEG, because we need to be able to fit all of it in memory. Okay? So this is kind of a stupid version of BitTorrent, if you will. Okay, so now he just spits out, we've locally buffered it. Now for the get guy, this dude here, we just received in the file size. So what we need to do is we need to initialize our file bytes. Except it's not going to be fizz available. Instead, it's going to be the file size. That is the number of bytes the server let us know. How many bytes the server told us it has to share with us. Okay, so there's the file bytes. And we're going to go ahead and we're going to fill up. So is it arrays or array? It's very strange. Didn't we use this last time? The fill method? Connected client. Yeah, arrays.fill. What's it screaming about?
To import it?
Probably. But I would have thought it would have just create class. No, you don't. Let me kill Eclipse real quick and reopen it. Eclipse is having a bad day. It says resolving model. So we're going to say the file bytes and then -1. It's very strange. I'm baffled. Baffled, I tell you. Does this thing even speak in Java? Raise is inside of java.lang. Isn't it funny you try to use a shortcut and it fails you?
Copy and paste where you imported it.
No, I didn't have to import it. Unless I don't think I had to import it. Oh, java.util.arrays. Okay, well that's all fine and dandy, but all right, whatever. They couldn't. Actually, do we have that problem last time?
No.
Didn't I have to go and look it up where it was and import it?
Oh, maybe. I don't know.
I kind of remember that. Whatever. So if you don't like importing stuff, you can just give it the full path to where it is. This was an exercise for the reader.
Did we pass the test?
No, every one of you failed. I was up here, I was floundering.
We were enjoying watching you struggle.
All right.
Funny picture to see you trying to like do the worm or something.
Do the worm? That's a dance, isn't it?
Yeah, but the same thing.
Oh, okay, that's good. All right, so this is our little shortcut, obviously. We're going to fill up our byte array with a bunch of negative ones. That means we don't have those. What's up?
A less short shortcut now?
Yeah, I think it's just because we were accessing a class. Rather than creating an instance of the class, we were accessing a class method of the class. Because this guy is a class method, because we're calling it from the class name. It must be Eclipse, just wasn't really equipped to do the whole reminder thing. We need to import something for you. So I'm pretty sure we had to look that up last time. Okay, so in any case, we went ahead and initialized our array. Now we're ready to receive these bytes. And we're going to have to figure out what this means. What does it mean to be ready to receive these bytes? Our goal is we want to fill up our array. But we need to fill up our array in such a way that we get each byte, not necessarily in order, but each byte, period, right? All right, so is there any reason? So if you have, let's just kind of make this a smaller version for us in real life. So we have an egg carton that has 12 empty slots for eggs. All right, and every one of you in this class has an egg carton that's partially filled up. Okay, one of you has the original egg carton, and this person is actually quite talented because they've actually been sitting there cloning eggs. Okay, they're not handing out things; they're cloning the eggs they have and giving them to other people. Okay, so it's a little bit of a sciencey thing. All right, it's high-speed cloning. So in any case, I go through and we'll index my egg carton. So this is going to be 0 through 11. Okay, I'm going to say, oh, I need egg 0, I need egg 1, I need egg 10, whatever. Okay, so when I say I need egg 0, who am I going to get egg 0 from? Who in here has egg 0 in their carton? Okay, and then who's the cloner? Tim. Okay, so we have two people. So the original cloner has egg 0, and Abe has received a clone of egg 0. So you actually have a clone of egg 0, not the real egg 0.
It's the same.
All right.
Not the two kids.
Okay. So punchline is that there's two people. So I'm going to send out a request I need egg 0. Right? And somebody now needs to respond to that request. So from a client's... Yeah, I got you. I got you. Wait, but do you know how to clone? Or do you have to go back to the cloner? Okay, so we're going to send out a request asking for egg 0. All right? And now I need somebody to fulfill this request. Who am I petitioning for this? Who am I sending the request to in our model here? Here's this guy. Here's me sitting here. So here's our cloner. Here's Abe over here. And he has 1 egg. He's just the one cloned egg. This is all I could do. I want to contribute. Okay? And I've come in and I've requested that I need egg 0. So I've requested it to the server. The server is then going to go and figure out who has egg 0 that is not currently busy. Does that make sense? Okay, so again, this is kind of a dumbed down model. We can certainly do multi-threading, and we can say that certain clients are able to do more things than other clients depending on the speed of their processors and that kind of stuff. But in this particular case, when I go to the server and I say, I need egg 0, the server is then going to look through its list. And what does the server have? It has this list right here, and it says, oh, well, right now it's just you two, but now we have C. So we'll put Abe in here. Okay, and Abe actually has 1 egg out of this is like Costco eggs. Okay, okay, this isn't 1 or 2 dozen eggs. You get 45,000 eggs.
So Abe is C.
Abe is C.
Okay.
So Abe, you have 1 egg, and the cloner over here is he's got a racket going. He's got 45,626 eggs. Okay, so I sent a request to the server that I need a egg at index 0. How did I know that? Because I looked at my array here and I knew that I did not have this guy. Okay, so the very first bucket I walked into, I noticed he was a -1. It's currently filled up with a -1, not a valid byte, not a valid egg. Okay, so I'm going to send a request. What's up?
It's a bad egg.
It's a bad egg. It was a non-existent egg though. A bad egg works for the analogy, I think. It's reasonable enough in our analogy. Okay, so I'm putting all my requests through the server. The server's job is not to transmit eggs. The server's job is to connect me with somebody who has the eggs. Make sense? So when I ask the server, I need egg at bucket 0, it's going to, in this particular case, say, this guy has egg at bucket 0. We'll have to figure out how it determined that I should get it from you rather than you. Because right now, both of you guys are doing nothing, right? Okay. Actually, in this case, maybe you are still cloning eggs for him. So as you requested egg 0, egg 1, egg 2, you're in the middle of giving Abe egg number 2, or egg at bucket 1, sorry.
So I got 2 eggs now?
It's in transit.
I thought you said in second egg was in transit. In bucket. The third egg was.
How many eggs do you have? Read that number.
Well, you told me the third egg is in transit, so the third egg.
That doesn't mean you have the egg.
Yeah, it's in transit. He's cloning it.
But you already just said.
Punchline here is he's busy. He is busy with your egg
He's
because
making eggs.
you've requested through the server that you want an egg. Okay? He was the only guy who had the egg that you want. And he was not busy at the time, but now he's busy. He's busy making you your egg. So when I came in and I requested an egg, it noticed that he was busy serving an egg to somebody.
Can you make
You're
us
not
all
busy
eggs?
serving an egg.
Can you make us all eggs?
No, eventually. Okay, so you're not busy. So the server's going to stumble upon you and say, okay, out of all the guys who are currently not busy, so we're probably going to have to maintain lists of who's currently serving eggs and who's currently not serving eggs. And when the client requests an egg, only the clients who are currently not serving eggs are going to be polled for who has the egg that you want. Does that make sense? It's like, wait a minute, what are we talking about?
Eggs.
Eggs.
Trying to figure out how.
Final exam, implement a dozen eggs.
Are these like chicken eggs or?
So in
Ostrich.
reality, who's the server?
Server. Who wants to be the server? You want to be the server? Okay. Okay. State Farm's the server. Okay. So I go to State Farm. I say, I need egg at bucket 0. State Farm looks around and he sees Tim over there hard at work cloning an egg. So what are you doing? Cloning eggs. Sees Abe is not busy. Looks at eggs. He looks at Abe's list of booleans, his array of booleans. Notices that in fact he has a true at bucket 0, which is the exact place that I'm interested in. So Abe has the egg that I want. Abe, you have my eggs. So the server here is going to play matchmaker. All right, so we're going to connect our sockets. I heard that when it was coming out. This is the problem with college folks. All right. So
Fork.
Fork the egg.
all right. So you're going to establish a communication channel between me and Abe.
You don't want him to say no.
All right. So we need to go back here.
You're losing that like Christian worldview.
Now here's the situation. In the model we just showed, even though this guy, this is Tim in our scenario here, right? This is Jake, this is Tim, this is Abe, this is me. So even though Tim already has all of the, in our stupid example here, all the eggs, okay, you have all the eggs, you'll never be requesting eggs. But in this case, well, here we go over to Abe. Abe has some eggs, but also needs some eggs. So Abe is in a situation where he's going to be asking for eggs as well as giving eggs. I haven't even said anything yet, and I feel it coming on. All right. All right. So in any case, every one of these clients, except the original, is going to potentially be sharing bytes and at the same time receiving bytes. That makes sense? The only person who won't be is Tim or any other clients who now have all the bytes. The seeders who, the BitTorrent seeders who no longer actually need files are just there to help everybody else.
For 2 seconds.
Until they come back and turn off the torrent. Okay? So now a client needs to be in 2 modes. Okay? They need to be in a share mode and they need to be in a receiving mode. So that means the client itself needs to be multi-threaded. The server is currently multi-threaded because the server has to be able to connect to another client, right? Things like that. Now, as each client, the server is maintaining these open connections. Let's model this out a little bit here. If we look at the server in general, that's our server. Okay, so here's our server. Our server, every single time we have a client connect, our server creates a connected client object and puts it inside of a response thread. So this is, I want to draw. Where's my, shapes. It's getting very sad there very quickly. All right, so this is our thread, and inside that thread, here. Inside that thread, we have our connected client. Perfect. Okay, so this is our connected client. And this guy is our the response thread. Okay, so every single time a client connects, one of these is created. Okay, this is on the server side. The server is still listening for incoming connections. That's shouting, but we're going to pretend like that's listening. He's saying, is anybody there? That's what he's saying.
Make it smaller, it's not shouting.
What's up?
Make it smaller, it's not shouting.
Who? Okay. So in any case, that's our server. Server's waiting for other connections. Every single time he gets a connection, he spawns off a response thread. And so this is a little worker bee that's connected specifically with this connected client. Okay. So every one of these clients is still connected to the server. Make sense? They're just waiting for the for the next interaction with the server. But their interaction from the server is going to happen through this response thread, not through the front door that they came through before, which ended up spawning off the response thread. So in this example, this is, let's say this is Tim, this is Abe, this is me. Okay? And each of these guys now has a part of the file, except Tim has all of the file. When I request, my communication channel here is through the server. I don't know about Abe. So if we just label these real quick, this is Tim. This is Abe. And that's me.
I'm the black diamond. Okay.
And that's State Farm.
Well, see, then you have to go Abe as the patriarch.
It's really hard to spell, and it really hasn't caught on, in my opinion. All right. That's his real name, by the way. It sounds hideous. All right, so this is Jake. Jake's our server, and so in our model we have this. Tim, you have all the bytes. Abe has, in this example, 1 byte, so we can even probably represent that. So what was it? 46,000. 45,626. 45,626. Abe has 1, and I currently have 0. All right, so that's the current setup. So Abe is both Abe is interested in getting bytes from somebody, as well as he has some bytes he can serve to other people. Okay, so before I even connected, since we kind of had this as a linear connection here, before I even connected, Abe had connected and made his initial request to the server. So Abe said, server, yelled up here to Jake, I need byte 0. Because he probably just went, well, egg 0, that's fine. So we can go back to bytes. It seems like bytes might get me into less trouble. All right, so I need byte 0. So maybe we decide that every client's just going to go through their array of bytes in order and then keep going through it over and over and over again until it's all non-negative ones. Make sense? Maybe it keeps track of every single time it receives a byte, and once that is equal to the length of its array, it says I'm done. Okay, so Abe is going to request a byte to the server. Jake is then going to check the people who are not busy, and when Abe first made that request, the only other client was Tim. So he looked at his list of non-busy people who are not currently serving bytes, said, okay, Tim is it. Let's hope for the best. Tim, do you have byte 0? He did. Okay, he didn't have to talk to Tim to do this because the server is keeping track of a Boolean array on Tim's behalf, right? So he checked bucket 0, that Boolean array, saw it was a true, and said, okay, this guy has it. He's not busy. So what I'm going to do is now I'm going to set him as busy. So he's going to put him over in the busy list. And now he's going to connect Tim to Abe and said, Tim, send him byte 0.
I send a response saying, please send 3 Bitcoin.
3 Bitcoins to this address, okay? So at the very least, our server needs to keep track of a couple of things here. We have busy, and not busy. Okay, so initially we have Tim, Abe, not busy. Okay, Abe sent out a request for byte 0. Tim isn't requesting any bytes. He already has all of them. So both of them are saying they're not busy initially. Abe sends out a request. Well, he's not going to fulfill the request himself, so he's off limits. Okay, so the server, Jake's not going to say, Abe, can you, do you have byte 0? When Abe had requested byte 0. All right, so he's going to find Tim. Tim has the byte, so he's going to add Tim to the busy list now, take him off the not busy list, and establish a connection between Abe and Tim. Okay, how is that connection going to happen? Jake has an open socket to Abe. Jake also has an open socket to Tim. How can that communication channel actually occur? How can Tim send a byte to Abe? Okay, Jake here has said, okay, Tim, I know you have the byte. You have byte 0. You don't have to check. You have it. Okay? So he needs to ask for byte 0 from you. And he needs to send byte 0 to him. Now what we want to do is we want to minimize the amount of data that actually has to flow through the server. Does that make sense?
Yeah, I don't want to do work.
I don't want to do work. Okay, but we also have to think about firewalls and things like that here. So how does this work? How do we have Abe, who is sitting in a sweatshop in Moscow, how do we have him establish a communication with Tim at Little Caesars, Grafton? Okay, when both of you are behind firewalls. You've both opened the communication channel, opened the door to the server. So that's why Jake has a communication channel with you. But Abe does not have a direct communication with Tim. How do we make that communication occur? What do you think?
The server might get the information from one and just resend to the other.
Okay. But then isn't the server then responsible for all that data? So we're using server bandwidth for that, correct? So the question is there a workaround? Is there a way to avoid that? So you're saying that maybe Jake stands up here and says, okay, I'm going to take the communication channel and I'm going to hold the hose together and just tell them to go. At the very least, it was close. But all that communication is still looping through the server here. Okay, so that means bandwidth is going from Tim's upload, going to the server, and then coming through Abe's download back to Abe. Because the server has a socket which has an input stream and an output stream associated with Tim. The server also has a socket with an input stream and an output stream associated with Abe. These are communication channels with each other. Can we have these guys connect directly to each other? If they're behind a firewall, we can draw a little firewall between these guys if it makes you feel better. There's the firewall. There's the firewall. So these guys are segregated from each other behind a firewall, and probably thousands and thousands of miles as well. Moscow is a distance. It's a distance.
Brisk run.
It's a brisk run. So, is the easiest solution here for our simple server to route everything through this server here? Now remember what we're avoiding. We want to take as much stuff off of the server as possible. At the very least, what we're doing is we're saying the server does not have to store data. All the server's doing is handing stuff off. It's receiving a byte, sending a byte, receiving a byte, sending a byte, so on and so forth. Make sense? Okay, so that's really the communication that occurs here on the server, as opposed to the server having to store anything. Now, what kind of becomes interesting as this relates to maybe how BitTorrent works. A lot of these, let's just call them illegal file sharing technologies that are out there, a lot of them base their legality on who is breaking the law and when. Okay? So, in this example, let's just say these guys are sharing for a first-run movie. If this guy is never actually storing anything, is he breaking the law? At the very least, let's say maybe not. Okay?
No, Abe might be.
Okay. Now, what if? So we're going to take a current first-run movie, and Tim has the whole movie. Is Tim breaking the law? He currently has the whole movie.
Depends how he got it. Is he an awards producer? That's
The awards person. Okay.
I don't think Tim is yet. He probably broke the law.
Okay. So Tim might be breaking the law. Okay. Tim has all the bytes of the movie and might be breaking the law just by having it. Okay. Now, when Tim sends one byte, well, in this case, he's going to send one byte to Jake, that Jake is then going to send over to Abe. For a moment, Jake has one byte of that 2 gigabyte movie. Is that breaking the law? One byte of it. It's his favorite byte. That could be
69.
That could be part of a Word document. That could be part of a picture. It could be part of anything. It just happens to be one of many, many, many bytes that were part of this file that in its entirety was illegal. Is it illegal for him to maintain that byte? He doesn't have the originally as a clone of it. Just the byte. Start seeing where this gray area comes in. Who's breaking the law and when? Okay, so it becomes kind of an interesting thing. But what we're going to do is we're going to have our server here in the middle. It received the request from Abe for byte 0. The server then went and talked. Well, the server then went and looked at its not busy list. Notice that byte 0 is there and Tim has it. He then moves Tim over to the busy list. He moves Tim over to the busy list. From there, what does he do? He's going to ask Tim to send him byte 0. So he'll send a request to Tim. Tim sends byte 0. He then sends Abe a response. So remember, this is how it happened. Abe asked Jake for byte 0. Jake went and looked for somebody that he had control of that had byte 0. He knew you had byte 0 and that you weren't busy. He put you in his busy list. Then he requested from Tim, send me byte 0. Tim sends byte 0 to Jake. Then Jake finally responds to Abe with byte 0. Does that make sense? And then that request is done. Okay.
45,525 times.
Well, that's why we're leveraging computing power to do this, right? That makes sense. He's fulfilling actually one of your threads. One of his threads is fulfilling that request. So once somebody, and this kind of is where we get back to right here. Where are we? This is the response thread. Okay, so this is the response stuff. So here's share, here's get. So if we're in getting mode, we send the stuff out for the client. Now, we're waiting for this client to connect. Okay, well, not waiting for the client to connect. The client's already connected. So we're here in getting mode. So this is one of Jake's spawn. His spawned threads. So this is one of your spawn threads, who's currently in a relationship with Abe.
Terry
Okay. And so Abe is going to send the request in here. So right here, for somebody who's getting things, we're going to have to say we're waiting for the client to request for receiving a byte. So let's say it that way. All right. So we might say something like this. This dot the client dot what do we call it? Get message. Okay, we're going to say which byte. And actually, what we can do is we can, well, it's fine. We'll just store it inside of that guy. So we're going to retrieve from the client which byte they're interested in. So this is when Abe spits out and says, I need byte 0. State Farm gets byte 0, then goes and checks his list. Well, what list? Who has the list? Well, here's our server. This is our server here. Our server currently has a list of all the connected clients. Now he's also going to need a list of busy and non-busy connected clients. So he knows who he can focus on when he has a request. Okay? So we're going to add to this. We're going to static linked list connected clients, the busy clients. And this is going to be a new linked list. And we'll also have a static linked list of connected client called the not busy clients. And this guy will be a new linked list. All right. So he keeps a list of all the clients, and when clients initially come in, when they join the list of all clients, are they also not busy right off the bat by default? Okay.
Would you even need the original clients list?
Potentially. You might want to just have a convenient way of accessing all clients, whether they're busy or not. So this guy here will maintain a list of all the pointers forever, as long as they're still connected. This guy is just going to have some of those pointers to those connected clients. This guy will have the rest of them. Okay, so these two lists split them. This guy is the one that has all of them. All right, so right here is where we say, actually, yeah, right here. As soon as somebody connects, we add them to the clients. We're also going to add them to the not busy clients. All right. Oh, thank you. Okay, not busy clients. So this is the exact same pointer. CC is a single pointer, single memory address. We just happen to have it stored in 2 places. So its pointer count just went to 2. Okay, so we've maintained that in 2 separate lists. Now, over here in response thread, we just read in from a get client a request for what files he, or what byte he wants. Now he needs to go, now the server needs to go and figure out who has this. So he's going to look to his non-busy clients. So he's going to say for, let's see, what is it? Connected client CC in driver dot the not busy clients. Okay, so for each of these, he wants to ask that client, do you have a specific byte? Okay, so we need to teach a connected client how to respond. So now we're back in connected client. We're going to have public Boolean has byte. We'll say int pause. And we're just going to return this dot my bytes at position pause, which will be either a true or false already because it's a Boolean array. Okay. Finally, we'll ask if cc dot has byte integer dot parse int which byte. If that's a true statement, then we need to share the byte with this guy. But we also want to say if cc is not equal to us.
Oh, it doesn't like that.
CC is a connected client.
You're in dot equals.
You're in response.
Is this dot the client thread?
I am in response thread. Oh, I'm in a response thread. I need a connected client. So this should be the client. This dot the client. Now, realistically, we're probably wasting our time asking this question. We would not have requested a byte if we already had the byte. Make sense? So now you make a decision from an. I realize we're out of time. Now you make a decision from an efficiency perspective. Are we better off asking the question, or are we better off just checking? Okay. For right now, we're going to leave it just to keep our logic going. If we're not going to ask ourselves, but if the person we're currently looking at is not us and they have the byte, then we need to share the byte with the guy that just requested it. Okay, so that's where we'll pick up next time. I will be giving you an assignment to complete part of this over the weekend, so you might want to start considering that. All right, I'll see everybody on Friday.